Hello, today we're going to be talking about the cross product. And so the cross product is going to be a vector operation that we can do on any two three-dimensional vectors. So I can do one vector cross another vector. And for 2D problems where we have kind of 2D vectors, we're going to need to add in a third component. We can just say, z equals 0 for both of those vectors and deal with it that way. But if we have two of these 3D vectors, we can perform the cross product. And the result of this cross product operation is going to give us a third vector. So I need two vectors and I get a third vector as a result. And the cross product in statics, at least, is going to be particularly useful for moment calculations. So in particular, a moment is going to be equal to the r vector crossed with the f vector. And you can see more about that on the moment about a point page in the adaptive map textbook. But we have a cross product in here, and it's important to know how to do this operation to get that result. Alright, so the cross product, say I've got three vectors here. I've got vector A, vector B, and vector C. And A cross B is going to be the kind of result, is going to be this vector C. So there's kind of two things I need to know about this vector. I need to know the magnitude and I need to know the direction. The magnitude, if we do this one way, is going to be the magnitude of the result. C is going to be equal to the magnitude of A times the magnitude of B times the sine of the angle between them. And so that gives us the magnitude, or kind of the length, of this vector here. Alright, so the direction, we're going to use what's called the right-hand rule. So if I take my hand, kind of like this, I'm going to stick my index finger in the direction of A, kind of my middle finger in the direction of B, and if my thumb is kind of pointed up like this, my thumb is going to be in the direction of the third vector, of C. So again, A is the index finger, B is going to be the middle finger, and then C is going to be your thumb. So this is going to be, kind of by definition, the direction is perpendicular, so C is going to be perpendicular to both A and to B. And so this is in a 3D space here. Alright, so to calculate that out by hand, I could use kind of the equations I had before, but if I don't know kind of the angle between the vectors, I just know the components of these vectors, there's another way to calculate this cross product by hand. So we're going to start by writing out literally letters x, y, z, and then we write x, y again. And then we're going to have kind of two vectors. Since the moment calculation is important in statics, I'm calling the first one r, second one f. And so in the second row of this, I'm going to kind of use, I'm going to do x, y, z, x, y, and then it's the x, y, and z components of my first vector, x and y components of the first vector, and this is my second vector down here, so x, y, and z components, and then x and y components of the f vector down here again. And so I'm literally just writing x, y, z, x, y, and kind of the components that correspond to those top letters for each of my vectors. Alright, so when I set this up, like so, this kind of is a way to get to the calculations I need for the components of my result. So, looking at each kind of moment vector, each moment part of this, mx, or the cross product, or the x component of the cross product, is going to be kind of starting at x, going this way, this diagonal, minus the diagonal starting at x going this way. And so I've got positive and negative. So it is positive ry times fz minus rz minus fy. And so that is the x component of my moment vector. I have another calculation for the y component. That one's going to be, starting at the y here, rz minus fx minus rx times fz. Alright, so that's the second one, and the third kind of component of this moment vector is going to be, starting at the z, that's rx times fy minus ry times fx. And so this is the x, y, and z components of my cross product here. So again, I've got a vector as my result. I had 3 components for R, 3 components for F, and now I'm going to have 3 components for my moment here. All right, so this is kind of the way to do it by hand. But really the true advantage of using the cross product for moment calculations and for other calculations for that matter is really when we use computer tools. So computers are able to do these calculations much quicker than kind of a person is able to do those calculations. So we can calculate the cross product in tools like MATLAB, which you may have access to, or we can do this in online calculators such as Wolfram Alpha, which will let you put in vector 1, vector 2, and it spits out the cross product in a matter of seconds. So with that, that's all I have for today. Thank you for watching, and I hope to see you again.